Have you ever just stopped and wondered how a universe that runs on simple, predictable rules can possibly create something as incredibly complex and, let's be honest, messy as life? Well, in this explainer, we're going to try and map that entire journey from the most basic laws of physics all the way up to the absolute mystery of consciousness. It's a huge story, so let's just dive right in at the very beginning.
Right. This is it. This is the one big question that's going to drive everything we talk about today. How do you get from simple, mindless laws to something as intricate, unpredictable, and just amazing as life itself? It's the central puzzle, and we're going to try to piece it together.
So to even begin to answer that, we have to start at the bottom, at the absolute foundation of everything. Let's get into our first section, the rules of reality. This is all about the physics and chemistry that govern the entire universe.
Okay, so you can think of physics as having two main toolkits. On one hand, you've got classical physics. That's the stuff that describes the world we can see and touch, gravity, heat, things falling. Then there's modern physics, which gets into the really weird rules for the super tiny quantum world and the supermassive scale of relativity. But for our story, the most important piece here is thermodynamics. It's the science of energy, and as we're about to see, life is basically in a constant epic battle to manage energy just to stay alive.
And that brings us to maybe the single most important idea for our entire map, emergence. This is the secret sauce, right? It's this almost magical phenomenon where you take a bunch of simple things, and when they interact, they create totally new and unpredictable properties that the individual parts just didn't have. Think about it. A single water molecule isn't wet. A single neuron can't think. But you put enough of them together, and suddenly, boom, new realities pop into existence. This is how the universe builds complexity out of simplicity.
So what's the very first great leap of emergence? It's chemistry. You see, the basic forces from physics tell atoms how they can connect and interact with each other. And out of those simple rules, you get the entire incredible world of molecules. This is the moment the universe goes from just a collection of particles to a truly creative canvas.
All right, now we're ready to climb up to the next level of complexity. Section 2, the spark of life. This is where non-living chemistry somehow makes the incredible jump to living biology.
So how in the world did chemistry become biology? I mean, this is still one of the biggest questions in all of science, but this timeline here shows our best guess. Picture a chaotic early Earth, about 4 billion years ago. Simple organic molecules start forming, and then they begin to self-organize. A lot of scientists think this led to something called the RNA world, a time when RNA, not DNA, was running the show, storing information and making things happen. And eventually, all this led to the formation of the very first primitive cells. And if you were to peek inside those first cells, you'd find life's core toolkit. These are the non-negotiables. You've got DNA, the master blueprint with all the instructions. You have RNA, which acts like a messenger copying those instructions. Then you have proteins. These are the molecular machines that do basically all the work. And finally, you've got lipids and carbs, which provide the structure and the fuel. Every single living thing you've ever seen is built from these same basic parts.
So how does the cell actually use this toolkit? The whole process is called the central dogma, and you can think of it as the fundamental operating system for all of life. It's a simple flow. Information starts in the master blueprint, the DNA. It gets copied into a temporary message, which is RNA, and then that message is read to build the proteins that go on to carry out every single function needed for life.
And all of this leads to a beautifully simple but incredibly profound idea, the cell theory. It just states that everything alive is made of cells, and the cell is the basic unit of life. See, a cell isn't just a random bag of molecules, it's another emergent property, a self-contained, replicating living system that is so much more than the sum of its chemical parts.
Okay, so we've got the blueprint. We have the first living cells. But a single cell is still a really long way from, say, an elephant or a giant redwood tree. So the next big question is, how does life organize itself into the stunning complexity we see all around us?
And that question brings us right to Section 3, the tapestry of being. This is where we zoom out and see how life organizes itself on a much, much grander scale, from individual organisms to entire planets.
And the scale of this organization is, well, it's just breathtaking. I mean, look at this ladder of emergence. Atoms build molecules, which build cells. Okay, we've covered that. But then cells group together to form tissues. Tissues form organs. Organs build entire organisms like us. And it doesn't even stop there. Organisms create populations, which form ecosystems all the way up to the entire living biosphere of planet Earth. Each and every step is a whole new emergent reality.
Now, for any complex creature to even exist, it needs to be constantly performing this incredible internal balancing act. It's called homeostasis. Think of it like a super advanced thermostat for your whole body. It's the critical process of keeping everything inside, your temperature, your blood sugar, all of it, stable and balanced, no matter what's going on outside. Without homeostasis, complex life would just fall apart.
So what's the force that drives all the incredible diversity we see across this huge hierarchy? Well, the engine of it all, as Charles Darwin figured out, is evolution by natural selection. It's such a simple but powerful idea. Organisms that have traits that are better suited to their environment are just more likely to survive, have kids, and pass on those successful traits. And over billions of years, that simple process has sculpted every single living thing on this planet.
So, you might be thinking, okay, this hierarchy is a cool abstract idea, but why does it matter to me? Well, it's not abstract at all. We use this map of life every single day. Modern medicine is completely built on understanding these different levels. Technologies like PET scans let doctors see what's happening way down at the molecular level, while an MRI can show us what's going on with an entire organ. We're literally using this map to understand and heal ourselves.
Okay, we've climbed pretty high. We've reached the top of the biological ladder. But there is one more emergent property, and it's maybe the most profound and mysterious one of all. Section 4, the final frontier, the emergence of consciousness.
So let's just start with the hardware, the human brain. It is packed with a staggering 86 billion neurons. That number is just wild. And each one of those neurons forms thousands of connections, creating a network so complex it's almost beyond our comprehension. And yet, somehow, out of all that biological wiring, our inner world, our subjective experience, just emerges.
But how? How does that actually happen? This is what philosophers and scientists call the hard problem of consciousness. We can track all the physical stuff. We can see which neurons are firing when you look at the color red. But we have absolutely no idea how that physical activity creates the private, internal, subjective feeling of experiencing the color red. It's a huge mystery.
Now, even though we don't have the answer, there are some fascinating theories out there. For example, global workspace theory suggests that consciousness is like a mental spotlight that broadcasts important information to the rest of the brain so all the different parts can access it. Then there's integrated information theory, which has this wild idea that consciousness is simply what highly complex interconnected information feels like from the inside.
Let's just zoom out one final time to a truly cosmic scale. Just think about this for a second. What if consciousness is unbelievably rare? What if, in all the mind-boggling vastness of space, this is it? It's a truly humbling and awe-inspiring thought that through our minds, the universe itself might just be waking up and becoming aware of its own existence.
So we've taken this incredible journey from quantum particles all the way up to the thinking mind. And as we look back across this entire map we've laid out, a deep unifying principle starts to come into focus.
Here it is. This is the deep insight that ties our whole map together. You see, the universe has this natural tendency to move toward disorder and decay. It's a process called entropy. But life does the exact opposite. Life is this little pocket of complexity that actively fights back against that chaos. And how does it do it? By using two crucial tools. It constantly channels energy and it processes information. From a single cell to a whole ecosystem, all of life is a beautiful, temporary rebellion against the tide of chaos. Which leaves us with one last, huge question to think about. Is the human mind, this incredible structure that's capable of looking back and actually mapping the very universe it came from, is this the final peak of complexity? Or are we just the latest emergent property in a cosmic story that is far from over?